Hello out there, thank you very much for joining me in this video where I'm going to talk you through the first one of 3 papers that Edexcel made for higher tier maths GCSE way back in 2017. And in fact this was the first ever of the new spec live papers that were given to students to sit in an exam setting. So when this came out, this was a pretty big deal, and because it's a brand new specification, the grade boundaries were pretty low. And also the difficulty is much higher. That said, it's reflected with the grade boundaries for passing being lower, so just bear that in mind. If you find these questions very hard at times, they are, but that said, you don't need to be a genius and understand every single question on every single topic to pass and pass well. So pick up the marks where you can, listen well, keep revising, and you should do just fine. That's enough from me. Let's have a look at what this paper actually looks like by tackling, first of all, of course, question number 1. So question 1 is a good old-fashioned scatter graph, and this scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. So 14 crosses for 14 towns. One of the points is an outlier. Write down the coordinates of this point. Well, first of all, what on earth is an outlier, you might be thinking? Well, an outlier, if I just underline the name, is just any point that doesn't really fit the pattern. So you see here all these points lie pretty much on a line. There seems to be a trend going on. There's a clear pattern. This one though is way out and doesn't sort of fit in with the others, so this is the one which is the outlier, so I'm going to circle that one. The coordinates of this one, we have to go 10 along, 19 up, so the coordinates are 10 and 19. For all the other points, write down the type of correlation. Now, what your teacher should have probably told you, almost as a knee-jerk reaction, scatter graph be thinking line of best fit. So now what I'm going to do, I'm going to draw one on for the other points, not including this outlier. The outlier is essentially ignored. The line of best fit looks something like this. First of all, line of best fit as well essentially does mean correlation. So with a line of best fit, we think about correlation. And here's a line of best fit like I promised you. So if you look at it, reading it like a book from left to right, as you move from left to right, what's happening here is that these points are going up as you move along. So as you move along, these points are going upwards. So you shouldn't do this, but you can think of it as being like this, like an arrowhead there. It's going up in that direction. So because it's going upwards, the line of best fit, it is in fact positive correlation. Part C, we're told on the same day in another British town, the maximum temperature was 16.4 degrees Celsius. Based off that, we're going to need to estimate the number of hours of sunshine in this town on that particular day. So what we do first of all is we find where 16.4 is on this vertical axis and read it off. So 16.4 is here. You then read along until we hit this line of best fit, but we don't go any further like this. Once we hit the line of best fit, we go straight down vertically and read off the corresponding hours of sunshine, which is going to be our prediction based on this line of best fit. So reading straight down, what we have here is nearly 13. Now each of these little squares represents 0.2 hours. So that's going to be 12, halfway between 11 and 13. 12.2, 12.4, 12.6. That right here is 12.8. So we just write down 12.8 hours. So that's your first mistake in there. I might well leave that in though, just so you can see that I do make mistakes, sadly, quite a lot. But that is meant to say 12.8 hours. How silly of me. So, the next one, the weatherman says temperatures are higher on days when there is more sunshine. So for question part D, does a scatter graph support what the weatherman says? Give a reason for your answer. Well, essentially yes, and the reason is because of this positive correlation. So as the number of hours of sunshine increase, you can see that the temperature tends to increase too. So in terms of what you need to put down for your exam, something along these lines should do you. Simply and importantly put yes, because sunshine is positively correlated with temperature. If you wanted to be as lazy as possible, you could probably just about get away with saying positive correlation, but I would strongly recommend that you give some extra wording and information to explain why you believe it is the case that the scatter graph supports weatherman. So we're off and running. That's question 1 done. Let's see what question 2 has in store. Question 2, express 56 as a product of its prime factors. Now, this is one of these factor tree diagrams which you may have seen before, and that you probably have seen. So we start with a number we wish to decompose, 56, and we branch off. On one hand, we think of a whole number bigger than one we can divide it by. On the other hand is the answer to that division. So what I'd suggest you might want to do is think, well, that's an even number. Yep, so any even number you can divide by 2. So I can divide that one by 2, and the answer to that is 28. If you want to double check that, you can use the old-fashioned bus stop method. 2 into 5 goes twice, with 1 left over. That 6 is now 16, then 2 into 16 goes 8. So on the other side, we put the answer. 56 divided by 2 is 28. Now what we need to do, because we want prime factors, if you see a prime number, which is a number which can only be divided by exactly 2 things, itself and 1, where itself and 1 are 2 different numbers, of course, we circle the primes, highlight them, and just leave them alone. So 2 is a prime number. It's the first and, in fact, only even prime number. So we circle that one. I'm going to highlight it, colour it in, so we leave that alone. 28, however, isn't prime, so we go again. So what can we divide 28 by? To speed it up, we can divide it by 2, which gives us 14. 2 is prime, 14 is not, so we highlight 2. 14 we can go again, because it's still even, we can half once more. So if we half 14, 14 divided by 2 is 7, but this time both 2 and 7 are prime numbers. So we're at dead ends everywhere. There's prime numbers at all these ends. That means we're done. The final step is we now say 56 equals all these numbers here coloured in yellow multiplied together. There's 3 2, so put down 3 2's. 2 times 2 times 2 times 7. And if you want to impress the examiner, I strongly recommend you write this in index form. 2 times 2 times 2 is 2 cubed times 7. And that is the best answer you can give. It's 2 cubed multiplied by 7. Question 3. Work out 54.6 multiplied by 4.3. I'm going to show you 3 different methods for this one based on the 3 main ways you can multiply numbers together. However, before I get started, I am going to say to you that when we multiply involving decimals, the best thing we need to do, in my opinion, is to pretend we have decimal blindness. So imagine what these numbers would look like if you couldn't see any decimals at all. We put the decimals back in after, which I'll explain. So the 3 methods, I'm going to have 3 boxes to show you. So this first one is the way I was taught. I don't really like this well, but it's probably the quickest. This is column addition. So again, like I say, imagining these numbers having no decimals, 54.6 would look like 546, 4.3 would look like 43. Using this method, what we do is we start from the bottom right corner and multiply all the numbers above, starting from the right hand side. So 3 times 6, first of all, is 18. We write 8, carry 1 along. So we multiply the 6, now we go for the 4. 3 times 4 is 12, plus this one is 13, so we write 3 and carry 1 along. Finally, we multiply that 3 by the 5 above it. 3 times 5 is 15, plus the 1 is 16. We're then done multiplying with the 3. We now move on to the 4. However, this 4 represents 40, so we put a 0 down here so that we know we're talking about tens, not just simply units. Next, 4 times 6. 4 times 6 is 24. Put the 4, carry the 2. 4 times 4 is 16, plus the 2 we're carrying is 18. Put the 8, carry 1 along. And finally, 5 times 4 is 20, plus the 1 we're carrying is 21. Now what we do is we add up all the big numbers, not these little numbers we've carried. We're done with those little numbers now. So, first of all, what we have, 8 plus 0 is 8. 3 plus 4 is 7. 6 plus 8 gives us 14. So we put the 4, carry 1 along. 1 plus 1 plus this extra carried 1 is 3. Finally, that 2 on its own gives us 23,478. However, we did say, didn't we, that actually these numbers have decimals in them. So this number here has got one number which comes after the dot. So that number here has 1 decimal place in it. 4.3 It's got one digit coming after the dot, which is the 3. So that again has one decimal place. One decimal place here, plus another decimal place there, means that in our answer, we want a total of 2 decimal places. We want 2 digits coming after our decimal point. So because of that, we need to put the dot before the 7 and the 8, so that the 7 and the 8 give us the 2 decimal places like we need. So our actual answer is 234.78. Next, I'm going to show you my preferred method, which is the lattice method. Now here you can do the boxes in any order. You just multiply what's above by what's to the side. So if I pick this box here first of all, for example, just picking it randomly really, 5 times 4, because above it is 5, to the right is 4, times them together, 5 times 4 is 20. I'll do this one next. 4 times 4 is 16, 6 times 4, 24. So you put the tens in the top left box, you put the units in the bottom right. If it was just units, you'd put a 0 in the tens and units in the bottom. That's how you do that. Going on to the bottom row, 6 times 3 is 18, 1, 8. 4 times 3 is 12, 1, 2. 5 times 3 is 15, 1, 5. You now add these up like a slide, so you go diagonally downwards, adding up as you go diagonally. So the first number here is just 8. The next one, 4 plus 1 plus 2, that gives us 7. The next one, quite a few numbers to add together, but it's doable. 2 plus 6 is 8, plus 1 is 9, plus 5 gives you 14. So then we write down the 4, we carry an extra 1 along to the next column, like so. So that 1 is just, it doesn't mean 11, it just means an extra 1 we're going to add on, okay? So this one now, 1 plus 0 plus 1 plus 1, that's going to give us 3. And lastly, just at the top, we've just got the number 2 on its own. So that just is simply 2. So again, the answer, 23,478. We need to put the dot back in the same way I mentioned before. 2 decimal places in the question. We need 2 decimal places in the answer. So we put the dot before the 7 and the 8. So again, 234.78. Last but not least, the other method is one you may have seen before called the box method. I'm not a major fan, but each to their own. To do this way, multiply the numbers, ignore the zeros. 5 times 4 is 20. Add on the zeros after. 1, 2, 3 zeros, so add on an extra 1, 2, 3. This one, we've got 40 times 40. 4 times 4 is 16. Add on 2 zeros. This one, 40 times 6. 4 times 6 is 24. Plus the 0 from the 40 gives you 240. Below numbers. 5 times 3 is 15. We add on 2 zeros. This box, above it is 40. To the right is 3. So 40 times 3 is 120. And lastly, 3 times 6 is 18 in that bottom right corner. Now what we have to do is, in any order you want, we need to add these numbers together. So what I'm going to do, fairly lazily, I'm just going to add these up going along like so. So 20,000 plus 1,600 plus 240. This is why I don't like it. There's a lot of adding up to do afterwards. But if you were to check that, you should find that gives you a total of 21,840. Next, if we add up these bottom numbers, 1,500 plus 120 plus 18, that's the same as 1,500 plus 138. That gives us 1,638. And then if you add these two numbers up here, 21840 plus 1638, you will see that you get exactly the same answer. So doing this really quickly, 0 plus 8 is 8, 4 plus 3, 7, 8 plus 6, 14, carry over 1, 1 plus 1 is 2, plus the carried 1 is 3, 2 plus nothing underneath is 2, 23478 is our answer. Pop the decimal place back in, and jobs are good. And again, 234.78. Take your pick, whichever one of those methods you prefer the most. Stick to it, use it, learn to love it. Question 4. We've got the area of a square. ABCD is 10 squared centimetres. We need to show that x squared plus 6x equals 1. This is where you might freak out because it's algebra, mixture of area. What's this going on about? Well, let's just think about area because it mentions area. So here what we've got is 4 separate areas to work out. We've got this square here, for example. So what would the area of this square be in the top left corner? Well, this square is 3 times by 3, so this square would have an area of 9. This one here, this little rectangle, is x wide, 3 long. So the area of a rectangle is length times width, 3 times x. This one here is 3x. This one here, again, it's x wide, it's 3 along. X times 3, or 3 times x, is 3x. Finally, in this bottom corner, it's x long, x high, x times x gives us x squared. So what we've done here, all of these bits and pieces added together will give us the total area of this square ABCD. But ABCD has a length, a total length of 3 plus x, and because it's a square, its width is the same as the length. It's the same going down as well. That's 3 plus x as well. So the area of ABCD is the area of a square. So it's 3 plus x times by 3 plus x. Okay, so it's literally the length times the width, as you'd find the area of any square or rectangle. But we've calculated here what this would be in terms of these bits. So the total area, which is this, must also equal 9 plus 3x plus 3x plus x squared. So now what we have to do is equate this, set it equal to 10. So the area of this square, we're told, is 10. Oops, wrong colour. So because the area is 10, we can set that to be equal to 10. So you could have done FOIL or using the grid method to expand this, or you could use the diagram. So we basically times out 2 brackets like this out diagrammatically using the diagram. You've got this. And we're told that the area is 10, so we just put that's equal to 10. Next, what we could really do with doing is simplifying this. So how many x squareds do we have? Well, we've got 1x squared. How many normal x's do we have? We've got 3 x's here, plus another 3 x's there. We've got a total of 6 normal x's, plus 9 units equals 10. Now, our target is to show this is true, so we want to get rid of that 9. How can we get rid of 9? Well, we could subtract 9 from both sides to clear it away. So minus 9 there, and minus 9 there, gives us, therefore, x squared plus 6x will equal 10 minus 9, which of course is 1, which is what we wanted to prove all along. So that's question 4 nicely wrapped up. Number 5. We've got a rectangular frame made from 5 straight pieces of metal like shown in this diagram. The weight of the metal is 1.5 kilogram for every meter long it is. Work out the total weight of the metal in the frame. So what you'll notice here is there is a diagonal piece of metal here. If it was just a simple rectangle, that would be fairly straightforward. We need to work out the length of this, because the length will link to the rate, and we need to work out about the weight. So we need to look at this diagonal, which is attached to, of course, a triangle. So if I just take this triangle, move it to the side, like so, I can label in what I know about it. So the bottom length is 12. This one here is 5. It's a right angle triangle. I know two sides. I want to find a third. So how do we do that? How do we find the third side if you know two already in a right angle triangle? It's that old Greek bloke called Pythagoras. It's this thing here. There's a nice visual of Pythagoras. So these two smaller squares equal exactly the big square. So a squared equals b squared plus c squared. So if that diagram is annoying you or it's putting you off, I'll just close that away. Hopefully you've seen it now. Bye-bye. So I'm going to call this A, because that's my hypotenuse. So call it h squared if you want, h for hypotenuse. So hypotenuse squared is 12 squared plus 5 squared. You need to know your square numbers for this. 12 squared is 144. 5 squared is 25. And that gives 169. How do you go from squaring a number to the square root? Sorry, to go from the number squared to the number without that, you have to do the square root of both sides. So therefore A must be the square root of 169. And be thinking right now, this is a non-calculator paper, so imagine that these questions are going to involve fairly nice numbers. They're not going to give you, very unlikely, they're not going to give you a question where you have to square root a really horrible number. So be thinking this is going to be a whole number, right? So I know 12 squared is 144. Try the one above it, that would be 13 times 13. So A, square root of 169, that's actually 13. So now I know what A is, I can add this to the diagram. That's 13. So now what we can do is work out the total length of metal. So total length of metal. Obviously we've got the top and bottom. So the top and bottom, because it's a rectangle, are going to be equal. 12 and 12, so 12 plus 12. So we've then got the sides. The sides are each 5, like you can see, that's 5. So that's 5. So plus 5 plus 5. And then finally, that diagonal we just worked out, which is 13. So a bit of adding up and then we're good to go. So just be careful if you're adding. 12 add 12 is 24. 2 5s make 10. 24 plus 10 is 34. 34 plus 13 is 47. So the total length of metal is 47 meters. We're also told, however, that the total weight of the metal is 1.5 kilograms for each and every meter we have. So if it's 1.5 kilograms for 1 meter, which is essentially what this is saying here, then we need to scale it up from 1 meter up to 47 meters. So what do we need to multiply 1 by to get up to 47? Well, we need to multiply by 47. 47 meters is 47 times as big, so that's going to be 47 times the weight of metal. So we need to do 1.5 multiplied by 47. Now, what I'm going to suggest we do here to make sure we don't go wrong when we've done all the hard work is to do this using long multiplication. So 47 times 1.5 we can treat as 47 times 15. Remember, when multiplying decimals, pretend you're decimal blind. So 5 times 7 is 35. 5 times 4 is 20, plus the carried 3, gives 23. New line, now we're multiplying with a 1. That 1 represents 10, so put a 0 because now we're talking about tens. 1 times 7 is 7, and 1 times 4 finally is 4. Now we add them all together. Apart from that carried 3, that's been used now. So now we're going to have 5 plus 0, which is 5, 3 plus nothing, which is 10. Put the 0 and 10 down and carry 1 along. And then finally 2 plus 4 is 6, plus the carried 1 is 7. Now 1.5 had one number coming after a decimal, so I need one number coming after the decimal in my answer. So it's going to be 70.5. So therefore the total weight of metal in this frame is 70.5 kilograms. And that's the answer, 70.5 kilograms. Question 6. You've got two lines here. The equation of line L1 is y equals 3x minus 2. The equation of line L2 is 3y minus 9x plus 5 equals 0. Show that these two lines are parallel. So, if two lines are parallel, they have the same gradient. Absolutely must have the same gradient. That's how you can define two parallel lines, actually. The gradients are the same. At this point, I want to remind you of the most obvious basic standard form of any straight line. The standard equation of any straight line can be given as y equals mx plus c. So if y is on its own on the left, if y is a subject, the number in front of the x, the m, is actually the gradient. So this here is the gradient, m. So for this one here, for L1, it's already in the form y equals mx plus c. So for L1, we know the gradient equals 3, because it's 3x minus 2. L2 isn't in this correct form yet. So for L2, we need to rearrange this equation. So it's y on its own. So we've got 3y minus 9x plus 5 equals 0 currently. We need to have y on its own. So I could get rid of that minus 9x. What's the opposite of minusing away 9x's? Well, if I added 9x, the minus 9x and the plus 9x would cancel. But to keep the equation balanced, if I add 9x on the left, I add 9x on the right. I then have 3y plus 5 equals 9x. I now want that 5 to disappear as well. How can I undo plus 5? I can subtract 5. So I'm going to subtract 5 from both sides. I then get that 3y equals 9x minus 5. But I don't want to have 3 y's, I want just 1. So to go from 3 y's down to just 1 y, I can divide by 3. But if I divide everything on the left by 3, I need to divide all of this on the right hand side by 3 as well. So then I'm going to get that y equals 3x minus 5 divided by 3. And you don't need to worry about this, it doesn't even matter. What does matter is that the number in front of the x is also a 3. So therefore, we can say for L2, just remove this line so it's a bit better. So for L2, the gradient equals 3, which equals the gradient of L1. They've both got a gradient of 3. Therefore, we can just conclude, because they both have this same gradient of 3, therefore we just say L1 and L2 are parallel. Question 7. There's 10 boys and 20 girls in a class. The class has a test. The mean mark for all the class is 60. The mean mark for the girls is 54. work out the mean mark for the boys. Now we're talking about means, averages. So we need to remember the formula for working out and calculating the mean. I'll remind you what it is. The mean is this. The mean is the total of all the values divided by the number of values you've just totaled up. So in terms of what we're talking about here, we're talking about mean marks. So the mean mark will be the total of all the students' marks divided by the number of students, because it's those students' marks we've added together. So it's the total marks divided by the total students. So because it's one thing equals a fraction, we can do this in what I like to call a magic triangle, like so. So this is what we can use. Now to work out what you want to work out, you simply just cover up with your hand or thumb what you're wanting to work out. So what I'm told here, first of all, is we're told the mean mark for all the class is 60. Okay, so from this line here, I know the mean is 60. It's all the class, so I know number of students as well. So mean is 60. Number of students, if it's whole class, it'll be the 10 boys plus the 10 girls. So we're talking 30 students. So we know the mean, we know the number of students. So for this bit here, I could work out the total marks. So if I cover up total, like so, the total of all marks, just look what's left in that magic triangle. I've only got two things left, two things right next to each other. In maths, if you've got two things next to each other with no mathematical instruction telling you what to do, it means that thing multiplied by the other thing. So I just times the mean mark by the number of students. So I just take 60 and multiply by 30. 60 times 30. 6 times 3 is 18. Add on the zeros. Now we're told something similar for the girls only. So for the girls only, we're told the mean is 54. Number of girls scoring that mean of 54, well, there's only 20 girls. So now we can work out the total marks for the girls only. So for the girls only, same process, we take their mean mark and multiply by the number of students. So it's 54 times 20 this time. So 54 times 2 is 108. Add on the 0, like this. So the grand total number of marks was 1,800. 1,080 was scored by the girls, so the rest of them must have been scored by the boys. So what we need to do here is to work out how many marks the boys scored is 1,800 minus 1080. 0 take 0 is 0. Nothing take away 8 we can't do. Let's borrow 1 from the 8, which becomes a 7. Move the 1 next door. That 0 is now 10. 10 take away 8 is 2. 7 take away nothing is still 7. 1 take away 1 cancels. So therefore 720 marks in total by the boys. So therefore the mean for the boys, now I want to work out the mean. I can move this hand to there now. Total on top, number of students on the bottom. So total divided by number of students. So it's the total marks for the boys, which is 720, divided by the number of students. In this case, because we're talking about boys, it's just the number of boys. We told us 10 boys, so it's 720 divided by 10. And 720 divided by 10, that 0 cancels that 0, we get 72 marks. And that is our final answer. Question 8, standard form. So write 7.97 times 10 to the minus 6 as an ordinary number. So what this means here, because that power of 10 is a negative, it's going to be a really, really small number. If that were 10 to the positive 6, it'd be a really, really big number. This power here, whether it be a plus or minus, tells us how many places and in which direction this decimal point moves. Okay, so what we're going to have here, I'll show you two different ways of thinking about it. I'm just going to write out the number as it looks with zeros either side, and I'll explain in a while what this means. So 797, some zeros that side as well. Okay, don't worry if this is making you think, what is he doing? It will make sense. Right, so currently, what I've got is the decimal is here. It's in between the 7 and the 9. Minus 6 means it's going to move that decimal 6 places to the left, 6 places in the negative x direction. So it's going to jump 1, 2, 3, 4, 5, 6. So it's going to be 0.000000797. And all the other zeros after we do not need. And the zeros in front of the first zero again are not needed. So that's our answer, 0.0000797. But just now, total up how many zeros come in front of your first 7. 1, 2, 3, 4, 5, 6, which is the same as this negative number. And that's your quick trick. If you need to write in standard form a power of 10 number which is negative, just stick that many zeros before your first non-zero number. So it's going to look like 797. Going to have 6 zeros in front of it. So I'm just going to go to 1, 2, 3, 4, 5, 6 zeros. Then just write 797. It's as easy as that when your number is times 10 to the minus something. Part B, unfortunately not quite as straightforward, but to be fair, not too bad as long as you just keep your head about it. So here, we've got one number divided by another. So what I'm going to suggest we do is take these numbers by numbers. So we've got normal numbers in my mind, 2.52 and 4, then powers of 10. Importantly, we're doing one number here divided by another. So first of all, let's do 2.52 divided by 4. So how many 4s fit inside 2.52? I'm thinking of this now in terms of sharing £2.52 between 4 people, although that'd be a strange thing to do, but it could be done. Does 4 fit into 2? Well, no it doesn't. 4 into 2 does not fit, so that 2 is still remaining. Make sure the dots line up, top and bottom. That 5 is now 25. 4s into 25 goes 6, with 1 left over. So then we put down 1 as the remainder. And finally 4s into 12 goes 3 exactly. So that's exactly 0.63. And so this here, that becomes 0.63, just dividing the normal numbers together. And now I need to multiply by 10 to a certain power. So looking at the powers of 10, I'm doing 10 to the 5 divided by 10 to the minus 3. Now one of the laws of powers, if the base values are the same, they are for both 10, if we're dividing these little numbers, what happens with them is we do one little number, subtract the other one. So the new little number, the new power, is going to be 5 minus 3. 5 minus 3, minus and a minus together make a plus. 5 plus 3 means the new power of 10 is going to be 8. And so what we're going to have next is this 0.63 times 10 to the 8. Now that's not quite in standard form. For a number to be in standard form, what we need is this first number here to be in between 1 and 10. So 0.63 is too small. So I need to put the dot in between the 6 and the 3. Then it becomes 6.3. So basically I've times this by 10 to make it the right size. However, if I multiply that number by 10 and don't change that one, I'm going to make it 10 times too big, which is not what I want. So to compensate, if I made this number 10 times bigger, I make this one here 10 times smaller. This is already in terms of 10, that just means I need to knock off one of these powers of 10. So if I lose 1 away from the 8 will become a 7, so I'm going to have 10 to the power 7. So my final answer for that one is 6.3 multiplied by 10 to the 7.
Question 9 is what we tend to call a reverse percentage question. So Jules buys a washing machine. 20% VAT is added to the price of a washing machine. She then has to pay a total of £600. What was the price of a washing machine with no VAT added on? So here we're told what the final price is, and we need to work out what the actual amount was before this percentage was added on. So I'm going to talk you through a few ways of doing this. So the first way is my sort of preferred way, and what I'd suggest saying here is before anything happens to an amount, we always start off with 100%. So start with 100% of the amount. So always start with 100%. So 20% VAT is added. So what we've got here is 100% plus this 20% added on gives us 120% of the pre-VAT price. Okay, so the price she ends up paying is 120% of the price it would have been without any VAT whatsoever. So how much did she actually pay? Well, it was £600. So therefore we can say that £600 is 120% of original. Now we want to find out what the price was with no VAT added. The price with no VAT added is the starting price for 100%. So we want to work out what 100% is. So far we know what 120% is. So now we need to think in terms of percentage parts. How can we go from 120% down to our target of 100%? Now there's a few ways of doing this. So what I'd suggest you might want to do is, if you can do, to find 1% of an amount. So what we could do here is find 1%, but what I'm going to suggest instead is we could work out what 20% is by dividing by 6. Because 120 divided by 6 gives 20%, and then we can do 5 lots of 20% to get up to 100%. So 600 divided by 6 is £100. 120 divided by 6 is 20. So £100 must have been 20% of the original price. Therefore, to go from 20% up to what we need, which is 100%, we can just multiply both sides by 5 now, and then we've got the answer we need. So times both sides by 5. We see that £500 must have been the original price. So our answer we need is £500. I'll just show you a graphic which might illustrate this a bit clearer as well. So in a similar way, you can picture it like this. So 100% is what we start off with, 20% is what's added on to that. And so 100% plus for 20%, that must be the full £600 like it says here. So if all of this is £600, you can see using this graphic there's 6 pieces. Each piece of 20% must be £100. 100, 200, 3, 4, 500, what you started with, plus the extra £100 which was VAT. 500 plus 100 does give the 600 as required. So there's a few different approaches, as there are for almost any question, but ultimately whichever way you go around it, you should find that £500 is the price before the VAT was added on. Question 10, we need to expand 3 brackets. So we need to show that x plus 1, x plus 2, x plus 3 all in brackets can be written in the form ax cubed plus bx squared plus cx plus d, where a, b, c and d are positive integers. That just means a, b, c, d are whole numbers. So it's written in a fairly intimidating way, but all we need to do here is to expand just two of these three brackets first, as you would do normally, and then your final step is to multiply it by the third bracket. You can only expand two brackets at once. My suggestion is you work from the outside in. So expand these last two brackets first, then after that we're going to multiply by the first bracket, x plus 1. So just focusing in on these last two here, x plus 2, x plus 3. Expand these using FOIL or the box method, whichever you prefer. I prefer the box personally. So let's expand this out like so. So these last two brackets, x plus 2 multiplied by x plus 3, do the boxes in any order. So if I do this top one, x to the side x above means I do x times x, which is x squared. This one here, x times positive 2 is 2x. This one is going to be x multiplied by 3, which is 3x. And finally, 2 times 3 gives positive 6. So what I have here, if I combine all this into 1, I'm going to have x squared. 2x's plus 3x's gives me a total of 5x's. And finally, the plus 6. And so this question here, leave that last bracket here, well the first bracket actually, until the last, and all I've done is taken these last two, expanded them, and shown that it's equal to this. So I replace these last two brackets with what the expanded version shows they're equal to, because they're one and the same thing. So these last two times out is x squared plus 5x plus 6. Now we've got to this stage, we just multiply the x by everything on the inside of this red bracket and then do the same with the 1. And we could do it using this box method as well. In case you're more familiar with FOIL, I'll show you an adaptation of FOIL which will work. We just take each thing in turn and multiply it by what's in the second bracket. So to start with, if I take the x, I need to take that x times it by x squared times by 5x, and finally times by 6. And so what I'll have here, by multiplying the black x by all of the stuff which is red, x times x squared will give me x cubed, x times 5x will give 5x squared, x times 6 is 6x. I then do exactly the same thing to the 1. So I do the 1 times x squared, I do 1 times 5x, and I do 1 times 6. 1 multiplied by anything just stays as it is. If you times by 1, it doesn't change the value. So this is going to be quite easy. 1 times x squared gives x squared. 1 times 5x is 5x. And 1 times 6 is obviously 6. So now if we combine everything which is the same sort of thing, I've got x cubes, x squareds, normal x's, and a number. So how many x cubes? I've just got 1 x cubed. How many x squareds? Well, I've got 5 of them here, plus an extra 1 there. That gives me a total of 6 x squareds. How many normal x's? I've got 6 normal ones there, plus another 5 normal ones there. 6 normal plus 5 normal x's gives 11 normal x's. And finally, plus 6. And that's the final answer. We're not told to write what A, B, C, and D are. If we did, we'd just put 1, 6, 11, and 6. But because we're not asked that, we just wrote it in the right form. That will do. If you wanted to expand this out using this box method, you should get something that looks a bit like this, by the way. So, because there's 3 things in the one bracket and 2 things in the other, it needs to be a 3 times 2 grid, and you would get exactly the same here, like I've shown at the bottom. So that's question 10 done in a couple of different ways. Let's now have a look at number 11. Number 11, we've got a graph drawn on a grid. It's a graph of y equals f of x. First it says write down the coordinates of the turning point. Well, the turning point literally just means where the graph goes from going downwards to going up, or from going up to going down. So the turning point is either the absolute minimum or maximum of the curve. So we're looking at this point here. So the coordinates are 1 along and 3 down. So the coordinates are 1 minus 3. For part B, we need to estimate roots of f of x equals 0. But f of x is y. So this here is exactly the same thing as saying whereabouts is y equal to 0. Well, y goes up and down. So when y is equal to 0, that means where y is on the x-axis, where the y line has a height of 0. So we're looking for this point here. It's where this curve in black crosses this horizontal line in blue. So you can see here it crosses in between 0 and minus 1. That to me looks about minus 0.7, maybe slightly less than minus 0.7. We're going to be as accurate as we can. This one here, that's 2.5, 2.6, 2.7. That's about 2.75. So as accurately as you can, for roots, like I said, where they cross, here and there, and as accurate as I could measure them, and the examiner will give you tolerance if you're a weeny bit out, so don't worry if you're not exactly the same as me in this, but you should have got minus 0.75 and 2.75. That's as accurate as we can go. So be as accurate as you can, but don't stress about being accurate to within needing a microscope to do the measurements. Finally, C, it says use a graph to find an estimate for f of 1.5. So what gets f'd, if you like, what we f is the x, so 1.5 is what x is. So in plain English, it's just asking what is the value of y when x is 1.5. So 1.5 and x are the same thing. So highlight where x is 1.5, and then we're going to read down till we hit the graph and then along to find the corresponding y value. And y is f of 1.5. So we're going to go down and along. You can see here it's about minus 2.8. So f of 1.5 is about minus 2.8, according to how you read the graph. Question 12, we've got some laws of indices and fractional indices at these. So if we've got a fractional indice where you've got a top number and a bottom number, I'm going to think in terms of flower power. So what do I mean by this? Well, a flower obviously grows. Touch wood, it does grow. If you buy them, you'd hope it grows. Where does a flower start off? Well, a flower always starts growing from the root, so we're going to start from the bottom number. So the bottom number is the root. So for example, if that's a 2, that means square root. If that number there is a 3, that would mean cube root. If that were a 4, it would mean the fourth root, and so on. So you do the bottom number first, then after the roots have taken hold, only after the roots have been strong, does the flower appear. Flower nicely rhymes with power, so the top number we consider to be the power. We do the power, the top number last, we do the bottom number first. So using that silly, although I think good analogy, let's have a look at part A. So the bottom number for part A is 2. So we're looking for a number we times by itself twice to give us 81. So essentially we're looking at the square root of 81, and we'll leave that minus 1, the top number, last. So what number times itself gives us 81? Well, that's got to be 9. So we've got 9 to the power minus 1. So if you've got something to the power minus 1, that's the same as saying it's the reciprocal. So any number can be written as a fraction. I'm going to rewrite 9 as 9 over 1. So the square root of 81 is 9, which is the same as 9 over 1. Now, any number or any value that's given to a negative power, we can rewrite this power as a positive by just flipping this fraction on its head. So this here equals 1 over 9 to the power positive 1. So I just flip this on its head like I say. get 1 over 9 to the positive 1, and anything to the power 1 is just itself, so 1 over 9 to the power 1 is just 1/9. So that's the final answer for part A. We're just going to have 1/9. For B, find the value of 64 over 125 to the power 2/3. So again, we're going to start at the bottom number, which means the cube root. So we don't just cube root the top or bottom, we cube root both numbers. We'll leave the top, the power, the flower till last. So we need to work out the cube root of 64 and the cube root of 125. And then afterwards, we can square. So bear in mind, this is a non-calculator paper, so be thinking these cube roots and square roots will likely be fairly nice numbers, and these are as well. So by trial and error, think of a number which multiplied by itself 3 times to give you 64. You should find that number's 4. And in the same way, what number times by itself 3 times would give you 125? Well, that number would be 5, because 5 times 5 times 5 gives 125. So we've got here 4/5 squared. So we've done the cube rooting. Now we can finally do the squaring. So we don't just square the top, don't just square the bottom, we square both numbers. So 4 squared is 16, and 5 squared is 25. And that's the final answer for 12B. Question 13 is about inverse proportion. So the wording of this is key. So it says y is inversely proportional to the square root of x. So starting with y, we're told it is inversely proportional. So we can set y equal to something. Now if it's inversely proportional, y is going to equal some constant number, k, divided by what it's inversely proportional to. If it were directly proportional, it'd be this constant times a number, but because it's inversely proportional, it's this constant divided by whatever it's proportional to. So it's inversely proportional to the square of x, which is another way of saying x squared. So that's the relation we've got to work with. And we don't know what this number k is. K just stands for some constant number which doesn't change, and we need to find it out. So this is an equation in terms of y, but we could do one step better because we could work out what k is. So to find what k is, we can substitute a pair of known values from this table. The easiest to suggest to substitute in would be these two values here. When x is 1, y is 9. So we're going to sub into this, x is 1 and y is 9. So y, which is 9, equals k divided by x squared. So when x is 1, that's going to be 1 squared. So in other words, k is just going to be equal to 9, because 1 squared is just 1. So k divided by 1 is just k, so 9 equals k. In other words, k equals 9. So we can replace k with what k actually is. We worked out by substituting 1 and 9 that k is 9. So our equation in terms of y is that y must equal 9 divided by x squared. Part B, find the positive value of x when y is 16. So we're just going to sub in that y is 16 now into this equation we've got. So we know that 16 equals 9 divided by x squared. My suggestion here would be to multiply both sides of this equation by x squared. So we've not got this x squared on the bottom of a fraction, which just makes it look a bit more awkward. So times both sides by x squared, we now have that 16 x squared equals 9 We want x squared on its own though. So that 16 is multiplying the x squared. Opposite of multiplying by 16 is dividing by 16. So we can have x squared on its own if we just choose to divide both sides by 16. So we have x squared equals 9 divided by 16. We want the positive value of x when y is 16. We've got the square root, so we can just undo the squaring by doing the square root. So x, the positive version of x, will be the positive answer to the square root of 9 over 16. If we're square rooting a fraction, we can just square root the top and then square root the bottom. The square root of 9 is 3. The square root of 16 is 4. And so the positive value of x is that x must equal 3/4 when y equals 16. Question 14 is a horrible ratio mix question. So we've got white shapes and black shapes that are used in a game. Some of the shapes are in circles, other shapes are in squares. The ratio of the number of white shapes to the number of black shapes is 3:7. So let's start with this. And there's a few ways of tackling this question, but I can't stress enough, this is a pretty nasty question, which really does ask a lot of your problem-solving skills. But I'll show you how to do it using one method, which I think is probably the easiest way of explaining it. So we've got white shapes to black in ratio 3:7. So first of all, what I'm going to do, I'm going to sketch out a little graphic just that represents the ratio of white to black is 3:7. So you've got something like this, 3 squares of white to 7 squares of black. The next thing we're told is a ratio of white circles to white squares. So this is just talking about the white shapes, so we're just looking at these 3 blocks here. But the ratio of white circles to white squares is 4.5. 4 lots of white circles to 5 lots of white squares. That's 9 parts in total, but I've only got 3 blocks here. So because that's 9 parts, but I've only got 3 blocks, I need to split each block here into 3, so I get 9 parts in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I can picture 4 of these little strips are white circles, and 5 of these little strips can be completed with white squares. But because I've divided all of these squares into 3 strips, for consistency, I need to do the same with these black ones as well. So like I say, 4 white circles and 5 lots of white squares. We now move on to the black shapes. The ratio of black circles to black squares is 2.5. Now this here is 7 parts, but here we've got 21 black strips to fill in. Now one way you could think about it is 2 plus 5 is 7 parts, but we've got 7 squares. So thinking in terms of either strips or complete squares, we essentially want 2 big squares to be represented by black circles, and 5 of these big squares to be represented by black squares. Think of it in terms of strips. I've got 21 strips here, but 7 parts. I could multiply this by 3 to make the numbers match. So if I times this one by 3, I've got 6.15. So I can have 6 lots of black circles here, and then 5 lots of black squares here. So that's my representation done. So if you're asking or thinking, how would you know to do that? Well, it's just experience and also just thinking of different ways of doing it. You could do a ratio table, which could show you a different time. But here, what fraction of all the shapes are circles? So I'm just after here, finding out how many are going to be circles. Well, I've got 1, 2, 3, 4 white circles, and 6 black circles. 4 plus 6 gives me a total of 10. Out of a total, of how many different bits are being represented. Well, I had 10 big squares. I divided each one into 3, so there's actually 30 different shapes here. A mixture of black squares, white squares, black circles and white circles. So it's 10 out of 30 in total, which of course simplifies down to 1/3. So 1/3 of all of these shapes would be circles. Question 15. We have a cone which has a volume of 98 cm cubed and the radius of it is 5.13 centimeters. Work out an estimate for the height of a cone. So first of all, let's just fill in what we know. So the volume is 98. Pi, well, pi is just a number. So pi, you should really know, it's about 3.14. It's just a number, but we can round that as well, because estimate implies round first. The height we want to know. So just filling in these numbers, the volume, which is 98, equals 1/3 times pi, which is about 3.14, times the radius squared. So again, this little r is the radius, which is 5.13. So we times that by 5.13 squared, and then times by the height. Now, because we're an estimate, we're going to round all this. So, if in doubt, we can take these numbers which we're not confident with and round to one significant figure. So, 98, that can round to 100. We'll leave 1/3 as it is for now. Pi is 3.14. Now 3.14 is pretty close to 3, so we can call that about 3. 5.13 squared, well 5.13 is about 5, so I'm going to call that 5. So instead of 5.13 squared, I'm going to do 5 squared times h. So that's what I've got here. So what I could do first of all, to get rid of this 1/3, is multiply both sides of this equation by 3. So 100 times by 3 gives me 300. And then I'm going to have 3 times 5 squared times h. Now 5 squared is 25. So I'm going to call that 3 times 25 times h. Now 3 times 25 is 75. 75 times h is 75 h's. So therefore, to have h on its own, I can divide both sides of this by 75. Or alternatively, I can think 75 times what number gives me 300. Well, a bit of thinking it through, you should find that's 4. So h, roughly, is 4 centimeters. So, John uses a calculator to work out the height of the cone exactly to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? So let's just think this through for a moment. If we're doing it exactly. Well, the exact number here, instead of being 100, that would have been 98. And so h would have been a number which is smaller than 300. Because rather than 100 times 3, would have done 98 times 3, which would be smaller on top. And this 75, well, where did that 75 come from? Well, it was 3, which is our rounded version of pi, If we didn't round and we did it exactly on a calculator, that would be 3.14. And 25 comes from the 5 squared, but actually it wasn't 5, it was 5.13, so exactly that would have been 5.13 squared. And so how would that affect the bottom of this fraction? How would this, if we're doing it exactly, compare to our 75? Well, because that's bigger than 3, 5.13 is bigger than 5, that would give us a denominator which would be bigger than our rounded 75. So you just need to show some sort of understanding of how the rounded fraction would be different to the exact fraction. So in terms of the answer, how would this affect John's answer? Well, our value of h, we're taking a fraction which has a denominator which is bigger than the actual, because the actual would be smaller than this 300, and we're dividing it by something which is actually smaller than what it should be. The exact is bigger. So the actual fraction we've used has got an inflated top number, and we're dividing it by something smaller. So our answer is going to be bigger, okay? Because if a fraction has a bigger top and a smaller bottom, that makes a fraction bigger overall. So a bit of an awkward way of wording this question, but something along these lines is what you need to put. You need to put your estimate will be more because my rounded numerator, this 300, is larger than the exact numerator. That would have been 3 times 98, which is smaller than 300. And you need to say that your rounded denominator is smaller than the exact denominator. Our rounded denominator is 75, but we rounded down pi from 3.14 to 3, and we rounded down the radius from 5.13 to 5. And so wording along those lines will get you the marks, but part B I do think is fairly awkward, to be fair. Question 16 is an algebraic proof. So we're told that n is an integer, which just means a whole number, which could be negative, but we're also told it's greater than 1. So in other words, n is just a whole number. So we have to prove algebraically that n squared minus 2 minus all of this in brackets squared is always an even number. So if it's an even number, it means it just needs to be a multiple of 2. So we need to prove that this is 2 multiplied by something. I'm going to focus on this bit here first. You've got a minus, all of this bracket, and minuses just make things harder, don't they? So I'm just going to focus on the n minus 2 squared first. So we can do this using FOIL, or we can use a box method, because n minus 2 squared means n minus 2 times n minus 2. So this is what I'm going to suggest we do here. So this here I'm going to write out again. So n squared minus 2 minus n minus 2 squared. I'm going to leave everything alone. I just want to work out what's in these brackets. So all I'm doing here is just working out, first of all, what this bit is. So n minus 2 multiplied by n minus 2. And we can do these boxes in any order. I'm supposed to do n times n first, which is n squared. This one, above it, is minus 2, to the side is n. So do n multiplied by minus 2, which is minus 2n. Down here we've got n times minus 2 again, so that's another minus 2n. Finally here, minus 2 times a minus 2, a minus multiplied by a minus gives us a plus. That gives us plus 4. Then we combine all these terms into 1 to get our simplified answer. So we've got 1n squared. How many normal n's? Well, we're taking away 2 there, taking away another 2 there, so minus 2 and then minus another 2. We're minusing away 4 in total. And finally we've got this plus 4 on its own. And so n minus 2 all squared is this, and so minusing away all of n squared minus 4n plus 4. So we're minusing away all of this. So it might help you to think of this as a bracket we're going to be expanding. If you want to, you can think of it as being minus 1 lots of all of this in brackets. But now, as long as we're careful, we can begin to neaten this up. So we've got n squared on the outside, but we're minusing an n squared here. So these n squareds will cancel. So we're going to have that minus 2 left. But then we're minusing a minus 4n. Minus 4n gives us plus 4n. Then I'm minusing a normal 4, which is just minus 4. So now I can neaten this up. So I've got 4n minus 2 minus another 4 is minus 6. Remember, an even number, that just equals 2 times a whole number. So I just need to rewrite this, what I've got here, as a multiple of 2. So I need to factorise out a 2. So to just drive home the point, I'm going to write it as 2 times, divide both by 2, that gives me 2n, half of minus 6 is minus 3. And I can conclude with a qualifying statement. So therefore, n squared minus 2 minus n minus 2 squared is always a multiple of 2, because it's got 2 times something, and therefore even, because saying something's a multiple of 2 is the same as saying it's an even number, because all even numbers are 2 multiplied by something. So that's all we need for question 16. Question 17, we've got 9 counters in a bag, 7 are green, 2 are blue, and Ria takes at random 2 counters from the bag. Work out probability that Ria takes 1 counter of each colour, and you have to show you're working. So one way we might want to choose to do this is by constructing our own tree diagram. So the first pick could be either green or blue, but she takes 2 counters, so we need to do another set of branches for the second pick, like so. So let's fill in these probabilities. So just think about the first pick. There's 9 counters to start with, 7 are green. So the chance of her picking a green to begin with is 7/9. 2 out of 9 were blue, so at the beginning if she picks a blue, that's a chance of 2/9. We now need to think about if she had have picked a green first. So let's ignore everything else and just focus in on the idea if she were picking a green first. So ignore the bottom. If she picked a green first, one of the 7 greens have gone, there'd only be 6 left. So to pick another green, that'd be 6 out of 8 chance, because there's 1 less in total and 1 less green, because 1's already been picked. If she picked a green first, both of these blues would still be left to be picked, so that'd be 2 blues left, but now out of a total of 8, because 1's just been picked. In the same way, think separately if she had have picked a blue first. If she'd have picked a blue first, all those 7 greens would still be there to be picked for the second choosing. But if 1 blue's been picked, there's 1 fewer counters in total, 1 fewer than 9 would be 8. Therefore, if 1 blue had been picked, there's now not 2 blues, there's only 1 blue out of a total of 8. So the chance of picking a blue for the second picking, if she picked a blue first time, would now be just 1 out of 8. So that's the tree diagram fully set up. And as a double check, what we need to be sure of is that each pair of branches adds up to 1. 7/9 plus 2/9 is 9/9, which is a whole 1. Good. Same here and same there. So it works fine. So now we can actually answer the question. We want to work out probability that Ria takes 1 counter of each colour. So this is saying here, we want the probability of green and then blue so that's one way it could happen. Another way it could happen though, or, now or I think of as being an add with probability, we could work out the probability that she picked blue first and then a green for the second pick. Now, just as I've said that or works as addition, and or and then works as multiply. So this and then I'm going to think of as timesing. So the chance of picking green first was 7/9. If you picked green first and then picked blue, that would be 7/9 times 2/8. Okay, because this scenario here relates to green, then blue, whereas this scenario here of blue and then green is going to be this scenario here. So chance of picking blue first would be 2/9. So I'm going to add 2/9, and then green second would be 7/8. So as long as we can remember how we multiply fractions together, we're pretty much good now. So first of all, 7/9 times 2/8. When we're multiplying fractions together, we just do top times top, bottom times bottom. So 7 times 2 is 14, 9 times 8 is 72. Over here, same deal, top times top, bottom times bottom. 2 times 7 again is 14, 9 times 8 again is 72. The bottom numbers are the same, so no need to change them. Because bottom numbers are the same, we just focus on the tops. 14 plus 14 is 28, all over 72, and that is your final answer. If you wish to simplify, you can. You don't need to, because it's a question about probability. So if in doubt, leave it out. Treat yourself to not having to simplify for once, because it's a probability question. 28 over 72. That's our final answer. Question 18. ABCD is a rhombus. The coordinates of A are 5, 11, and the equation of the diagonal DB is y equals a half x plus 6. Find an equation for the diagonal AC. So what I'm going to do here is just pick out this information and add it to the diagram. So the diagonal from D to B, which goes from here to here, that's y equals a half x plus 6. We're interested in the diagonal AC, which goes from A to C, like so. And you might be thinking, well, how on earth do I do that? Well, it actually links back into the properties of 2D shapes. So what's one of the special properties of a rhombus? Well, it's basically a diamond shape. All the sides are the same, not going to help as much. We need to be thinking of the diagonals and where the diagonals cross. Where does this red cross the blue? And what's special about these angles here? Well, if it's not coming to mind, I'll just tell you now. For any rhombus at all, the diagonals of any rhombus intersect at 90 degrees. And so this angle here is going to be a right angle. So this is going to help us massively, in fact. Diagonal DB, this one here, this is in the form y equals mx plus c. So m is half. The gradient of the diagonal from DB is a half. So the gradient of DB is a half. Now, because the red is perpendicular to the blue, we need to be thinking of negative reciprocal. So the gradient m of a diagonal from A to C is going to be the negative reciprocal of a half. So -1 divided by a half, or just flip this on its head and stick a negative sign in front, 1 over 2, change it to 2 over 1 and make it minus. The gradient of AC is -2. So for the diagonal from A to C, we've got y equals mx plus c, which is the general equation for any straight line. But we now know that the gradient of it is -2. So what we can do here is we can say that actually, we know the gradient's -2, so I'm going to stick out a -2 there. We just need to work out what this C is. So do we know any other information about this diagonal AC? Well, luckily, actually, yes, we do. Because we're told a point on this line, we're told point A. So we're told that A is a point 5, 11. So we can substitute that point in. So now we can sub in that when x is 5, y is 11. We're just basically substituting in point A into this equation. So y now is going to become 11. X is now 5, so minus 2x means minus 2 times 5. And finally, plus c. So 11 equals minus 2 times 5 is minus 10, plus c. I can work out what c is by adding 10 to both sides. So therefore c would be 11 plus 10, which is 21. So AC is y equals minus 2x plus c, but we have just worked out that c is 21, so it's minus 2x plus 21, and that's our equation for the diagonal AC. Question 19, a fairly nasty vector question. So I'm going to just pick out these bits of information step by step. So the distance from O to A, going from O to A in the direction from O to A is vector A, and from O to C is vector C. X is the midpoint of the line from A to C. So get this labelled on first of all. Call X something like this. Then it next says about OCD being a straight line, so that OC to CD as a ratio is k to 1. So OCD is a straight line, so from O to C, D needs to be somewhere out here. So I'm going to draw this on and label that point D. Then we're told about a vector going from X through to D, which is 3C minus a half A. So I'm going to get that labelled on as well, like so. So that's 3C minus a half A. We need to find the value of K. So what we need to think about here is how we could get from O all the way to D. If we can work out the distance from O to D, we can then compare with O to C, get it into a ratio, and then work out what this K factor must be. But first of all, what I'm thinking of doing, to get from O to D, could we go via this point X? Well, actually, yes, we could. So to go from O to D, I could go from O to X, and then, once I'm at X, I could go from X to D, which is this one in green. But the thing is, how do I go from O to X? So what is the vector from O to X? Well, X is halfway in between A and C. And so, first of all, let's think about what AX is. From A to X, it's only halfway from A to C. So it's halfway from A to C, because X is half the distance. And then to go from A to C, well, from A down to C, I'd have to go from A to O. A to O is along A, but in the opposite direction, so that's minus vector A. And then from O to C is just vector C. And so that's AX. So from O to X, I could go from O to A first, and then from A to X, and then from X to D. So all I'm saying here is that from O to X, you can think of it like this. So now I can actually work out in terms of vectors what this is. So from O to A, from O up to A, that's just vector A. Then the vector from A to X, I've just worked out what this is here. So it's A, then plus half of minus A plus C. And then XD, we've been taught XD as it's 3C minus a half of an A. So, just make myself a bit more space. So if I expand this out now, half times minus A, that's minus a half of an A. Half times C, that's plus half C. Plus 3C minus a half of an A. Now look at the A's here. So I've got an A here, but if I take away half of an A and then take away another half of an A, I've got no A's left. So the A's cancel, which is what you'd expect because A is going upwards. From O to D is a straight line, so it should just be along this vector C, which it is. So how many C's do I have? I've got half a C here, plus another 3 C's. I've got 3.5 lots of C, so I'm going to call that 3.5 C. Okay, so now I'm almost done. So therefore the ratio of OC to CD I can work out. So from O to C, that was just one lot of vector C. But then from O through to D, that's 3.5 lots of C. So if that's one lot already, the total distance is 3.5 lots. From there to there, it must be 2.5 lots. Because 1 plus 2.5 gives us 3.5 lots of C. So the ratio of this is 1 dot dot 2.5. But here it's in the ratio K to 1. Okay, so I need to get this into the correct ratio. So this is in the form n to 1. So here, it doesn't really matter how you do it. What I'm going to suggest is we get rid of this decimal by timesing both numbers by 2. So if we do that, we get 2 dot dot 5. And then I can now divide both of these numbers by 5. So I've got this n number as a 1, which is what it needs to be. So 5 divided by 5 is 1. 2 divided by 5, I can either leave it as 2 over 5, or I could write it as a decimal as 0.4. So either 2/5 or 0.4. So if you see here, that's a 1, that's a 1, so the other number must be k. So I've actually worked out now what k is. So we just conclude by saying, therefore, k equals 2/5, or if you're a decimal person, you could put 0.4, and that also is absolutely no problem at all if you were to say that. Question 20, a very tricky simultaneous equation question because one of these isn't linear. So solve algebraically the simultaneous equations. X squared plus y squared is 25, y minus 3x equals 13. It does say algebraically, so you can't do it as trial and error. How you would do it as trial and error anyway, I don't know. For these equations, what you need to do is, with a linear one, get y in terms of x or x in terms of y. and then substitute it into the other one, which is non-linear. So here, if I add 3x's to both sides, I can see that y equals 13 plus 3x. And so what we do now is we use this expression for y and pop it in to the other equation. So I'm getting slightly hoarse. So we just take this top one and then we input y as 13 plus 3x into it. And so this now is going to become x squared plus y squared, which is 13 plus 3x all squared, equals 25. So we've got some expanding of brackets to do here. So 13 plus 3x all squared. So you could use either FOIL or the grid method, as I'm going to show you here, either or. But multiplying a bracket out by itself just means you write every bracket out twice, essentially. So it's 13 plus 3x times another 13 plus 3x. So you can do these brackets in any order. So 13 times 13, that's 169. This box, 3x times 13, is 39x. This one down here is 3x times 13, which will give you another 39x. And this one in the final corner, 3x times 3x. Well, 3 times 3 is 9. X times x is x squared. So what this is going to give us overall, we've got 9x squareds, as we can see. In total, 39 normal x's plus another 39 normal x's gives us 78 normal x's, and plus 169. So I'll stick this to one side. So essentially, this I can replace with that, because that is what this is when it's expanded out. So I've got x squared plus 9x squared plus 78x plus 169. Equals 25. So now we need to simplify this. So x squared plus 9x squared, that's 10x squared, plus 78x plus 169 equals 25. Now if I'm going to try and factorise this, it's a non-calculator paper, so I'll be thinking factorising it, if possible. I need to get everything onto one side, so it equals 0. So I need to take away 25 from both sides of this equation, so I've got 0 on this side. So then, you're going to have 10x squared plus 78x, 169 minus 25 is 144, and that's going to equal 0. Now, because I'm solving an equation, I can try and make the numbers as small as possible by dividing through by any common factor. So here, if you look, 10, 78, and 144 are all even numbers. So we can make our job slightly easier if we just divide through by 2 to begin with. So dividing both top and bottom by 2, left and right by 2, I mean 10 halved is 5, so that gives us 5x squareds. Half of 78 is 39, so that gives 39x's. Half of 144 is 72. Now we can factorise this, and your teacher may have shown you various ways of factorising out something like this. It will factorise. Here's what I'm going to show you now. So what I'm going to do, I'm going to slide and temporarily forget this 5x. So I'm going to times that 5 by the 72. And I'm going to then forget this 5 at the front for now. So I'm just going to leave it as just a normal x squared plus 39x. 5 times 72, if you try that, well, that'll give you 360. Now I factorise this in the normal, easy-ish way, where I just think of two numbers that multiply together to give me 360 and add up to give 39. So there's lots of different combinations here. So I could try 1 and 360. Obviously that's not going to work. 2 and 180. That's still too big. 3 and 120. So anyway, if you carry on and on, by trial and error, you should find eventually you get 15 and 24. And those are the two numbers that will work. 15 times 24 is 360. Add them together, you get 39. So now put these into brackets. So I've got x plus 15, x plus 24 equals 0. However, I did sort of forget about that 5 at the front. Now it comes back. What we do here is we divide both these numbers at the end by that number we've forgotten. So just write these all over 5. And what we do now is we simplify if possible. If you can just divide exactly, do the division. So 15 divided by 5, you can do that. So I can replace that with just 3. 24 over 5, does that simplify? It doesn't. If you've got a situation where it doesn't simplify and you still have a denominator, which isn't just 1, you shove the denominator back next to the x. So then I have 5x plus 24. Therefore, we can now see the two solutions of x, which would work. In fact, we could see a solution of x here. Anyway, either this bracket or that bracket is equal to 0, because one bracket times another gives us 0. So therefore, one solution is x is minus 3 for this bracket, or, I'll section this out as well, x would be minus 24 over 5. If x were minus 3, remember y is 13 plus 3x, so y would be 13 plus 3 times minus 3, which would give you plus a minus 9. In other words, y would be 13 minus 9, which would be 4. So you've got here one solution set, x is minus 3 and y is 4. The second half of the solution is thinking if x is minus 24 over 5. If that were the case, then y would be 13 plus 3 times minus 24 over 5. Now here we're talking fifths. Okay, so I'm going to rewrite 13 as a top-heavy fraction over 5. So if I times 13 by 5, that's going to give me 65. So that's the same as 65 over 5. 3 times 24 is 72. So 3 times minus 24 is minus 72. So I've got 65 over 5 minus 72 over 5. That gives me in total minus 7 over 5. So the next solution is that x is minus 24 over 5 and y is minus 7 fifths. So that's the complete solution. So you have two different solutions, each for one of the two different values of x. For question 21, we've got ABCD as a quadrilateral. We're told that AB equals CD, angle ABC equals angle BCD, and we have to prove that AC equals BD. Now this is one of the last questions, hence why it's a pretty challenging question, because it's actually hard to know what to do first of all. But if we're told that certain angles and sides are the same, then we should be thinking of a word similar and congruent. And in particular, this is going to link to splitting this quadrilateral up into two different triangles, both triangles including AC and BD, and then we're going to try and show that they must be the same length too. So knowing what to do is the hardest part of this question, but what we need to do is as follows. We need to consider two triangles, ABC and BCD. So ABC is this one I've picked out. So it goes from A to B to C, then back again, whereas BCD is this one. So I'm picking these two out and just drawing them separately. So let's just consider what the question says. So first of all, we're told that AB equals CD. And so this length here, AB, is the same as this length here on this one, CD. So I'll just highlight those as being the same. And I'll write this down as well for my own notes, that AB in the red is the same as CD on the blue triangle. The next thing we're told is that angle ABC, this one here, is the same as angle BCD, this one here. So if I highlight these in green, then these two angles are the same as well. And the last thing to mention, and is fairly obvious to see from these diagrams, both triangles share the side BC in common. They've both got a side BC. And of course BC is the same as BC because BC is, well, BC. So that side here and that side there are the same. So now you might be thinking, well, so what? But it's at this point we need to remember the rules of triangle congruency. We've proven that each triangle has a side which is identical, an angle in the middle which is identical, then a side, the other side of the angle, which is also the same. So you've got two sides and an angle in between, which are the same for both triangles. Side, angle, side. Side, angle, side is one of the tests of two triangles being identical to each other. If one side's the same, the angle in between is the same, and the side on the other side of the angle is the same for both triangles, those triangles have to be identical. So because we've proven that these two sides are the same, the angle in between is the same, therefore, because the triangles are congruent, the other side must also be the same. So we just need to conclude by stating the following, really. Just say, based on this here, and just reframing the question in the way I have here, or something similar, we can say, therefore, AC equals BD, because triangles ABC and BCD are congruent by side, angle, side congruency. So I would mention SAS in your answer, definitely, because that shows evidence that you know the test of triangle congruency. So that shows understanding by writing SAS and showing that a side, the angle, and the side are the same in both of these two triangles. Question 22 is pretty much from hell. This was so challenging that there was a big kick-off about the question, and other websites on the internet also did their own solutions to this question. It became fairly infamous for its difficulty. So I'll try and talk you through it in the best way I can. We've got this hexagon A, B, C, D, E, F. And A, B, E, F, so the parallelogram on this side is congruent, identical to the parallelogram on this side. So BE is a line of symmetry. Because there's so much information, I'm just going to copy this diagram to the other side, so I've got more space to add information to it. So let's talk it through step by step. First of all, we're told AB is the same as BC, I'm going to call that X. So let's call that X here. The next thing I'm going to highlight is that BP, this one from there to there, is the same as from B to Q, and we're going to call that 10 centimeters. So I'm going to get that labelled on as well. The next thing that I'm going to mention is that ABC is 30 degrees. So this angle here is 30. And we're wanting to prove that cosPBQ is this horrible looking expression here. So cosPBQ is the angle made as you go from P to B to Q. So angle PBQ is this one here. So I'm going to put that one there. So it says here as well about P. P is a point on AF, so from A to F, and Q is a point on CD, so here. So we're told that that's 10 centimeters. And as well, because P and Q are the same in each of these shapes, the distance PQ will be the same for each of these. Okay? So, next up. Because PQ is the same, and AC is directly above, from A to C and from P to Q have to be the same length. So AC and PQ are exactly the same. Now look at these triangles, the red one and the blue. I've got two sides and an angle between, and I don't know the length of the side opposite. Same here, I've got two sides, 10 and 10, an angle in between, and I don't know PQ. But PQ is the same as AC. And this is a general cosine rule question, where you know two sides, or you're interested in two sides and an angle in between, and you don't know the other side. So to remind you of the cosine rule, it's this. So I could just call side A, this one here between A and C. I could also call it between P and Q, because PQ is the same length as AC. So A here, I'm going to label as A on these ones. So looking at the red triangle, A squared will be x squared plus x squared minus 2 times x times cos of 30. And looking at the blue one, A squared will be 10 squared plus 10 squared minus 2 times 10 times cos of B, which is PBQ. So both of these expressions, the bit in red and the bit in blue, they both equal A squared. And so what I can say from this is that therefore the red is the same as the blue. So this thing here is the same as that thing there, because both are equal to A squared. So I'm going to set these two equal to each other, and we can neaten this up as well as we go. So x squared plus x squared in the red, I can say that's 2x squared. And this bit here has got cos 30, and if this question wasn't hard enough, you need to remember some exact trig ratios. So I'm not going to make the video even longer than it is, but just to refresh you of what the exact trig ratios are for angles of 0, 30, 45, 60 and 90. Here's a little table of reference. So cos 30 is what we've got here. So cos 30 is root 3 over 2. So this here, I've got minus 2 times x times x. So that's minus, well, x times x is x squared. But here, if I've got root 3 over 2 times by 2, that'll just leave me with root 3, because the times in by 2 and the over 2 will cancel. So the cos 30 bit will just simplify to root 3, because I'm timesing it by that 2 at the front, and x times x is x squared. It's only the 3 of it she's being square rooted, so 2x squared minus root 3x squared. And then here, in the blue, I've got 10 squared plus 10 squared. Well, 10 squared is 100, plus another 100. That's going to give me 200. Change colour so it's in blue so it matches nicely. That's 200. Then minus 2 times 10 times 10. Well, 10 times 10 is 100. Times by 2 is 200. So minus 200 lots of cos PBQ, which is what we're trying to show is equal to this thing here. So if we have a look at our target here, I've got the 2x squared and the minus 3x squared. But here that needs to be a minus 2. It's a positive 2 here. And this root 3 needs to be a minus. That root 3 needs to be a plus. So what I'm going to do here is just multiply both sides of this by minus 1. Just so I can get it closer to what the target needs to look like. And if I do that, this minus root 3 is going to become a plus root 3x squared. It just switches the signs from plus to minus or minus to plus if you multiply by minus 1. So this 2x squared becomes a minus 2x squared. On the other side, the minus 200 cos PBQ becomes plus 200 cos of PBQ. And that positive 200 becomes a minus 200. So next what I'm going to do, so it looks a bit more like this, I'm going to factorise out the x squared from this side. So I'm going to have this as being a 2 and a minus root 3. If you're thinking, but that's a minus 2, don't worry, I'm coming back to this in a moment. I'm going to stick a minus sign in front, so it looks like my target. So I'm always trying to prove the target, so you're trying to aim to have the thing you're trying to prove look like what it needs to be. Then over here, what I can do is I could get this cosBPQ on its own, but the first thing I'm going to do is just to rewrite it as it is. I'm just going to take it nice and slowly, step by step. 200 cosBPQ minus 200. To get this cosBPQ on its own, I'm going to add 200 to both sides. So the next step, if I add 200 to both sides, then what I'll get over here is 200 minus, in brackets, 2 minus root 3 x squared equals 200 cos PBQ. Now comes the final step and the final piece of the puzzle. So now I can just divide everything by 200. So therefore I can say cos of PBQ equals 200 minus 2 root 3, in brackets still, 2 minus root 3 x squared, and all of this is going to be divided by 200. So I'm going to divide this by 200 first, and then I'll divide this by 200 after. And if I do it that way, it will look exactly like it needs to, okay? Because 200 divided by 200 gives us 1. And then I can leave this as it looks, because that's how it needs to look there anyway. So minus 2 minus root 3 all over 200 x squared. And we've proven what needed to be proven. So that's the final question on the paper, therefore the paper is completed. So hope you found that useful for some questions. Thank you for listening. Please do subscribe and like, and be in touch for the next video. It's coming up soon. So again, thanks for your time, good luck with your revising, and take care. Until next time.